All right, so for 5.2, like I said, we are not actually learning anything new as far as new identities. We're just using the same identities in very similar ways. So your only goal is to verify identities here. Okay, you've already taken a second to write down these hints, so you can just keep these and read through them if you get stuck. All right? And let's try an example with them then. Okay. For the first example, we want to verify that the following equation is an identity. What that means is that you want to pick one of the sides, whether it's this side or this side, and you want to work on that side until it matches the other side. Like I said, you are not juggling things back and forth, so don't go adding things to both sides or subtracting things from both sides. You need to work strictly with what's on one side and just modify it to look like the other side, and that's it. Remember that one of my hints was that you want to start on the side that looks more complicated. In this particular instance, I think it'll be just as easy either way, but just to kind of stick to what I'm saying as far as typical things to try, which side would you start on? The left-hand side looks more complicated. What are you thinking? So we're trying to condense this down to just the cosecant squared. What are your thoughts? Yeah? Yeah, no, you can't just take it out of the cosecant. Yep.
Could you make the cosecant 1 over sine squared theta?
Sure. Yep, let's try that. So he's saying to take this guy right here and make it be, so it would look like the cosine squared of theta, and then that would drop down to be on the denominator as the sine squared of theta, right? And then we still have plus 1. Now what? Yep.
You can multiply
Don't work on both sides. Yep. So just work on that one side. Assume that you don't have another side to multiply to.
Cotangent.
That's the cotangent squared, right? And now what do you see? That is a Pythagorean identity. We have an identity that says that the cotangent squared of theta plus 1 is equal to the cosecant squared of theta, right? So I need to make sure that I have both of my sides equal by the time I'm done with this, and they do equal each other, so I'm done. Easy as that. Yay. Ready for the next one? Okay. This one, same thing. So on all of these, you guys, I'm doing 4 examples, and each of the examples is just giving you more ways, more examples of ways that these can go. So for this one, again, you want to verify that the following equation is an identity. Okay. A lot of times what I'll do, and actually, I'm going to, hold on one second. All right. So sometimes it's going to be beneficial for you guys to work on both sides. That's why I centered this, just so that I could work on both sides if I need to. I'll just draw a bar down the center of this, just so that I'm able to see which side is which usually. Which side do you guys want to start working on? Which one looks more complicated to you? I would say the right side. They're both about equally as complicated, but I'll start on the right side. What do you want to do on the right side? We're on the right side, not the left. Difference of 2 squares. So when I FOIL that all out, what is it going to be? And then what do you notice? Okay, so now we've kind of reached a point where this is what I'm talking about, where it might be beneficial to work on both sides, because my right side is now way more simple than my left side, right? So it might be worthwhile to stop on the right side and now take what I have on the left and try and morph it into the sine squared. Okay? What do you suggest I do on the left-hand side if that's my goal? Okay, so she wants me to do the sine squared of x over the cosine squared of x for the tangent. And then on the bottom, she wants me to say, okay, this is 1 over the cosine squared of x. Now what? Okay, so on this same step, I can multiply by the reciprocal, so I can get rid of this if I multiply by cosine squared of x over 1. Now what do you notice? Those cancel out, and did we get what we wanted? Yeah, you got the sine squared of x. Again, you should be ending, oh, I'm sorry, I all of a sudden changed to x instead of theta. Or I was doing theta over here when I shouldn't have been. These should have been x's, sorry. But we got the same thing on both sides, so that is done. Okay, let's look at another example. Which side are we starting on? Left or right? I would say that we want to start on the left. All right? So I'm going to draw my line down the middle again just so that I can keep track of where I'm at. Pick a side to work on. We said we're going to start on the left-hand side. What are you going to do? What are your thoughts?
Denominators are almost a difference of squares, so if you have the same denominator.
Create a common denominator, and that common denominator is going to be the difference of squares, right? When you multiply those two together. Exactly. So what I can do here is start making one big fraction, and I know that my common denominator is going to be 1 minus the cosine squared of m. What is going to be on top then? So what does this 1, what would I have to multiply this 1 by in order to force a common denominator here? Yeah, 1 plus the cosine of m. So basically, for this denominator to become the common denominator, I need to multiply the top and the bottom by this part. Okay? Plus this one, what am I multiplying this one by in order to get a common denominator here? Very good. 1 minus the cosine of m is what I would be multiplying by there. Now you notice that, what do you guys notice about the numerator here? The numerator? So pretend that I didn't have, maybe it'll help you. Let's say that I didn't put parentheses around these things. Because really, do I need the parentheses when I have a plus in between? This might help you see. What can I do? Yeah, I can cancel out the cosine of m's. So what's left in the numerator? 2. What's in the denominator? That is a Pythagorean identity. That is the sine squared of m. Okay? Now what? Yep. So at this point, you can reciprocate this up by changing it to the cosecant. And what do you notice? They're the same, and so we can be done on that one. Okay. Something to note, you guys, the whole point of these problems is the work that you're showing, right? You must show me each step. Otherwise, I'm going to wonder how did you get there? Okay, so even if it's something that you see in your head, write out the step. Otherwise, you're not going to get the credit. The whole point of these is showing somebody each logical step in the proof. That's the whole point. All right? Yes?
Would it be wrong if you left it as 2 over sine squared m, and then on the other side you change that to 2 over?
Nope, because in this, all you're trying to do is get them to match.
Okay.
So that, as long as you did change the other side, that's fine. Last one. All right, let's put our line down the center so I know where I'm working. Okay. Which side do you guys want to start on? Which one do you see things that you can do? Because they're both about as complicated looking, right? Which one do you see things popping out at you a little bit more? I would say the right side has something pretty obvious happening. What does it have happening? I can factor, right? I mean, the other side, I might look at that for a little bit and be like, oh, I'm not really sure where I'm supposed to go with that, right? So let's simplify the factoring side first and see where that takes us, and then we'll go from there. What does the top factor into? What? Do we agree? Yeah, that's 1 minus the cosine of x quantity squared. Okay? That still is over the negative sine squared of x. Is this the Pythagorean identity? No, it is not. That squared would have to be only on the cosine, right? All right, what do you propose I do now? Ignore the fly. Okay, what do I do now? Yeah. I would probably do that in the denominator, and we could probably actually do that all in this step. So what we're looking at is, rather than rewriting the sign, what could I replace that with? One minus the cosine squared, right, of x. And I kept the negative tacked on up front, but I kind of looked at this as though, like, okay, sine squared of x, I'm replacing what's in the parentheses with 1 minus the cosine squared.
So you don't like carry that in if it doesn't have a 1?
I will carry it in, but wait,
What
what?
I did wrong on my problem where I was like, I took it out, but because there's a negative there, it didn't work.
All right, what are we thinking? I'm just going to let you guys look at it for a little bit. We've got time. For starters, I would maybe, here, I'll see if I can get you guys going. If I were to, on the bottom here, distribute the negative in, this would become -1 plus the cosine squared, right? Which, switch those terms around, would be cosine squared of x minus 1, right? Yes.
Did you factor the bottom?
You sure could and you should. So now he just said, well, can I factor the bottom because that's a difference of perfect squares? And I said, yes. If I factor the bottom, I get the cosine of x minus 1, and I get the cosine of x plus 1. I'm really close, right? On this term right here, what do you notice? And it might actually, guys, okay, bear with me, but I'm going to back up, and you'll see why. I'm ending up kind of redoing steps right now because what I'm about to have to do is that I want to be able to cancel these, right? But I can't cancel them until they're in the same order, which means I'm going to have to take a negative out of this term. But that's just undoing what I did up here at this step. Do you see what I'm saying? So I can save myself some steps if I leave the negative out. And yes, you are going to, this is a perfect example of you're like, oh, I already wrote it all out. Okay, you are going to be erasing a lot when you are doing these. So you just get used to it. Okay, it's not that big a deal to backtrack a couple of steps. So on this step, what I'm saying is keep the negative pulled out And then what we're going to do is just factor out this part with the negative outside of it. So if I factor it in that form, now what did the factors look like? And is that in better form than the way I had just started doing it? So it was worth it for me to back up because now this cosine cancels with one of the two. Yes?
Could you just pull out a negative of the numerator instead of?
No, because that one's being squared. I mean, yeah, no, you couldn't, because then you would switch both of those terms. And you'll notice that the one that I have left over is in the form of 1 minus the cosine of x. If you tried pulling it out of the term that's squared, the term that would be left would be cosine of x minus 1. That would be the opposite sign than what we want it to be. So I was able to cancel one of those, and now I'm left with negative 1 plus the cosine of x, right? Do we agree? Okay. Is there much more I can do with this side? Or do you want to start working on the other side? What do you guys want to do? Yeah, I'd probably switch to the other side at this point. I mean, I could distribute that negative through, but that's not really going to make or break trying to match the two sides together. So let's look at my left-hand side. What do you propose I start by doing? Notice that my right-hand side is now in terms of cosine, right? What do you think I should do to the left side then? Put it in terms of sine and cosine. So it's going to kind of turn into a nasty fraction at first, but it'll simplify down. So the very first term, the cotangent of x, can be written as the cosine of x over the sine of x. That's minus the cosecant, which is 1 over the sine of x, all over, and on the denominator, the cotangent on, it's the same exact terms except for with a plus in between, really. So I'm going to copy exactly what I've got with a plus. What do you notice is nice about these fractions, though? They've already got the common denominator, right? So I could write this as the cosine of x minus 1 all over the sine of x all over the cosine of x plus 1 all over the sine of x. What do you see now? Yeah, so I'm going to multiply up by the reciprocal of that to get rid of it on the bottom, which will be the sine of x over the cosine of x minus 1. And then you get even more nice things happening because these cancel. Oops, that should have been a plus 1, sorry. And now you're left with the cosine of x minus 1 all over the cosine of x plus 1. We're really, really, really close. What's the only thing that I have to do? And it might be easier to modify this side to look like this side. What's the only thing that's different? Not taking, yeah, I see what you're saying. So she's saying, can I take a negative out of the top here, switch the terms, and then cancel them? Yes. Or you could also take this negative and distribute it into the top and switch the terms. Either way, what it's going to look like is if I do exactly what she said, if I take a negative out of the top up here, then I switch my terms. Also notice that the bottom, I can rewrite in the parentheses that is cosine of x plus 1, right? Ooh, sorry guys, I know I'm running out. Can you guys kind of see that? No? Okay, let me redo that. I'm not sure where to go with it, but, oh yeah, okay, I'll go this way. Negative, so we switched the order, and then what I was just saying was on the bottom, to make it look exactly like the other one, I can change the order of addition without having to pull a negative out again, right? So all I did was, on this guy, I just switched within the parentheses those two. Now what happens is these two things turn to positives, and you've got exactly the same piece on both sides, so you are done. Okay, so that's the idea with these identities. Here is your homework. You've got a little over 10 minutes to get going on a few of them with your partner. This will be due on Monday.